Welcome! In this video we are going to build a full face recognition system using machine learning on a network. It's called GATE, as in keep you at the gate if you are not recognized, or let you in if you are part of the database. How it works. GATE clients, after authenticating, they can add and remove users to their employee database running on Postgre. GATE clients are part of a database of GATE users with ID, name, email, password hash, and machine learning model. They can manage employees, where besides the usual name, age, income stuff, to which we have a table for that, we also have a table for employee photos, where, as you are expecting, we take a bunch of photos from the employee and add that information to his record. Then GATE users can train a classification model with the current employees to make it available for all machines that control door access, so that when a local machine has someone at the gate, it sends an image sequence to the server and the server replies yay or nay, to which the local machine then either opens or keeps the gate closed. To keep this simple, I condensed this into a single web application, but you get the point. For the second video, if you like this, we will focus on the ML ops side of it. We have Prometheus listening for CPU, memory, disk usage, network traffic, and latency. It sends email when something is off. And MLflow to track model metrics drift, deviations from accuracy, precision, and recall. If for some reason we get a drift where the model starts falling below a certain metric threshold, Airflow is triggered and retrains the model automatically. As for requirements, you can use your operating system of choice. I used Ubuntu for this. VS Code with Python, Postgre, Docker, Docker Compose, Google Cloud Console, Prometheus, MLflow, Airflow, a camera, OBS, oh yes, and lots of coffee. Right, so now that we have this out of the way, the first thing to understand about when we are creating a project for machine learning specifically, for all of them, but for machine learning specifically, you're going to be required to import a bunch of libraries. And in order to not affect the global environment, you want to be specific to the GATE project environment or any other future projects that you would have. So what we do is create a virtual environment. And that way, whenever you make imports, those are specific here to GATE project or the future projects that you do. So all the imports that you do, it's not like a bunch of them just for all of them. It's just specific for this specific project. So to do that, we're going to do Python -m venv venv, and this is going to create a virtual environment for the GATE project. And now we're going to activate the virtual environment, and to do that we're going to do source venv bin activate. Okay, notice here that we have the virtual environment here that is activated. If you wanted to deactivate it, just to show you, it's just to deactivate. If you want to get it online again, so this is how we activate it. And just to clear the console a bit to make it clearer. Right, so now we can add the folder to the workspace. It makes it easier for you to see all the files that go inside that specific project. So we're going to do open folder. And then here, in my case, is desktop, then YouTube, ML projects, GATE project. Select folder, open. And now we have this specific project that we are working on. Okay, so let's get this out of the way. And now inside of GATE project, we're also going to create our file. And we'll have further files to work on, but for the most part, the main file will be app.py. This is the main file that we will be working on. So just open the terminal again, just for us to see our work, then clear. So we have our virtual environment created, we have our app.py, and now we're going to take care of the imports. There are a bunch of them, and I'll go through what each one means. And you might be asking, how is it that you get to so many imports like from one go? I don't. As I start working on a project and I start seeing I need this and I need this and I need this, so I look to the imports that are required to do that specific task. And then in the end you have like a bunch of them. So first we'll start with Flask imports. Flask is a framework for building web applications from the server side. It will integrate with the front end of the application. So we have a bunch of them here. So take time to pause this video and check each one of these. I will explain to you as we go through this tutorial, but these are the main ones for Flask. These next ones are for security and password management. And these next ones are for database management. And next you're going to need to do some image processing and machine learning. And these are the libraries to do that. So OpenCV is for image and video processing that will allow us to see like the video feed and all that. NumPy is for the operation, and all these TensorFlows and all that, all those are specific to the classification model. Specifically here we're going to use ResNet 50. Later on I will explain how this model works. Note here specifically that I've added type ignore to all the TensorFlow ones, and the reason for it is that the TensorFlow doesn't have accurate type hints, and this causes type checkers to raise errors even if the code runs fine. So this is to avoid annoying alerts from the console. And finally, these are some utility libraries that we will be needing in our program. So again, we have our Flash core imports, we have Flash extensions and authentication, we have stuff for the database, we have stuff for the image processing and machine learning, and some utility libraries. Let's keep going. So to install all of the stuff, I'm just going to copy this here so you can see it better before we put this on the console. Copy this specifically here. Just going to get this on top here so you can see it, and let's go. Right, now a couple of things. Here specifically I already have this folder added to the environment, but most likely you're going to encounter a problem where when you start running this it won't work. If that's the case, if you encounter an error and you can't for some reason run the code, what you do is you go here and do Python, and now here you're going to import one of them. So let's say it's NumPy, and then you're going to print the stuff. I'm going to show you to you how this works. You're going to print NumPy dot file, and you want to see the path where this library is, and you're going to copy all the stuff until packages. You're going to copy that. You go to this cog here, click settings, and then here notice here what we have. It's like, looks like a file or a shirt. You're going to open the settings, the JSON file, and note here that this is working because I've added this as an extra path. If you don't have that, most likely you're going to encounter an error here. So you're going to paste that part here. So here specifically, so you're going to take that path, I'm just going to take it out, and just going to pass it in here. And then here in command palette or Control-Shift-P, same thing, you're going to do developer reload window. When you do that, try running this again. So we go back to app.py and try running this again. Here mine is running. If for some reason yours doesn't run, this is what you're going to do. Here, just going to add print hello. And now here, instead of using this play button, you're going to do Python app.py. So this is running. All these warnings, you can disregard these because this is about the CUDAs for the TensorFlow. I'm using an older computer and this doesn't use a GPU. This is the warnings that we're having here. So you can disregard these. You note here that it didn't run print hello. So when you do that again, now it's going to run it. I don't know why this works, but it seems to be on the second attempt that you do that. So now, because this is working, I can either use this one, so it will work, and you have the hello, or I can just use Python app.py. In either case, it will work. Let's continue with environment setup. So now we're going to load the environment variables from a .env file. Then we're going to set up a login configuration and suppress some unnecessary warnings. And then we also have these two lines here, and what they do is sometimes we have some errors in regards to characters. So to do that, we're going to reconfigure those and encode those back into UTF-8 so that we don't have those errors anymore. Next, we're going to set up our Flask application. So app equals Flask name. And then we're going to set up our environment variables, our database configuration, and our database engine. So our environment variables are these that I'm going to show you here. So this is the base environment. So it's a base directory for the application, the path for the model storage, and the database configuration. Pool size is a number of max connection availables for use, and max overflow is a maximum number of connections that can be created beyond the pool size. I've defined my database as DB3, and note here that the secret keys and all this will be information that is inside the .env file. It's essentially a placeholder for the API keys, secrets, and all that, so that information is not in the app.py, but it's in a separate file. Next, we're going to initialize the Flask extension. So it's a database, the OAuth for Gmail, and the bcrypt for hashing the passwords. This next chunk is to configure the OAuth providers, in our case Gmail, which is the one that we're about to use. Note here again that the secrets and all those are in the .env file that they can be retrieved from the os.environ.get, and all the remaining information comes from Gmail directly. Before starting with the classes, we're going to add a decorator to ensure that the database connection is always closed after each request, which is a good standing practice. And now let's start with the classes. For our Postgre database seen from Python, we're going to have essentially 3 classes. The first one is gate client, so the person or entity that is going to use our web application. The second class is employee. These will be all the employees that a gate client can assign to the app or remove them from it. And in addition, we also have another table that is employee photos. So each employee, we have the basic stuff, so name, income, job, and so on. And we also have a different table with the employee photos. So you're going to take a bunch of photos from that employee, and those will be stored in a separate table. So we're going to pass for now. As for our first class, I'm going to copy the code here for you and explain to you as we go along. So the table name is gate users. We're going to have an ID, username, email, password, hash, and OAuth provider, in our case Gmail. Then we're going to have a relationship from one to many, so employees. So a gate user has many employees. We're also going to store the train model and the label dictionary. So the key here is that when a gate user, after adding employees, starts training the model, that model will be stored in his table. But we're also going to store the label. So let's say label 1 is a coffee cup, the second label, let's say, is a CD, the third label is a mouse, and so on. So you'll be having a relationship of the train model and the label dictionary. Then this next function is going to set a password, so we're going to keep it in a hashed string from the hash to see if the password that was input by the user is correct or not. This is the function that is going to save an instance of the model in that specific user ID. This is the model path. This is standard to check if the directory exists, if not, create it. And here, specifically for performance issues, I decided to create a temporary file in a specific path. The whole idea to this is that we're going to cache this specific file so that it's retrieved from the database once, but then when we're going to make inferences, meaning when we say like we have a video feed and a bunch of employees, and when the model is making an inference, if that person is like A or person B and person C and so on, it's not going to the database directly, it's going to that file directly, that temporary file, that is going to get deleted after we change users or log off his session. This chunk is related to the model, so it's self-explanatory. Essentially, we are reading the save model into bytes. Here we save the label dictionary and JSON in the database. Remember here that before, besides his own credentials, we also save his employees and his train model and label dictionary. This is what we are referring to. And this is standard to commit the changes to the database. And in addition, as I explained, we're going to clear the load model cache for this client. And now we have a couple of class methods, and I'll explain to you what these mean. When you create an instance of a class, you usually see self, because self is related to the instance of that class. But these class methods are referred to the class only, not the instance of the class. So these affect the class only. This is why you see CLS as in class. The whole point to this that I made here in my notes, it's to load the model once from the database. It's going to keep that in a temporary file so that when the model makes inferences, it's faster because it's loading from the cache. Here, this class method is to remove the model from the cache. It's going to clear it out for that specific ID user. And lastly, this one is to create the model, as I explained. So you're going to load the information from the database, and then you're going to make inferences from the temporary file that we have just saved. Let's move on to the employee. So now here this is simpler. We have the ID, same as always, name, age, job, income, and get client ID. The whole point to this is that each employee is going to refer to a specific foreign key ID. So when a Gate user creates John, Susan, Mary, Richard, and so on, all those are assigned to that unique Gate user ID. So let's say we have 3 clients, 3 IDs in our Gate app. So let's say ID 1 created like 10 employees. So all those would be referring to that specific foreign key. About these ones, we are setting up the database columns. So these are database, and the format is integer, string, and here specifically is 100 characters. Nullable means it cannot be none. Moving on, I created a separate table for the employee photo so that we can essentially separate types of concerns that we are doing. So the table name is employee photos, same as before. We have a relationship to that specific employee, specifically the foreign key employee ID. Similar as before, as we did with Gate users, that each Gate user has many employees, so it's a relationship from 1 to many. Here it's the same thing. We have one employee with a relationship from 1 to many, because he can have multiple pictures assigned to him. And we are done with our classes. Next, we need to check if a Gate user is logged in by verifying his client ID in the session, and this is the code that does that. We use this reps decorator to ensure that the function retains its original name and docstring. The whole point to this is to ensure that the users are logged in before accessing certain routes. So this is why the login required comes about. So this is the concept of login required. You need to be logged in order to access this specific page, and this function ensures that. This first one is for the login. Note here that the methods are get by default and post, obviously, because we are going to add information to the server. Here, this is the information that we add to the server, so is ID and password. This is the information that's going to be validated from the database if the user exists or not. And then it's to check the password, and if it logins successfully, it's going to be redirected to the dashboard. And this login router is going to render the login HTML template. So that login form that you see when you enter any app, this is the part that takes care of that. It's going to render that specific HTML page that was built for that. Moving on, this next route is about the user to register. So again, it's get and post, because we're going to put information in the server and retrieve information from it. So it's username, email, and password to register the user. Here we need to enforce basic validation, meaning all fields are required, so we can't skip any fields. And we're going to render the register HTML template for that. These ones are self-explanatory. These are to filter if the username already exists, or the email or the email was already registered, so it was errors in that sense. Else, we're going to take care of hashing the password for that specific client and logging in the user to the dashboard. And the specific render template for this one is a register.html file that we're going to build in a couple of minutes. These next 2 routes are related to logging in with Gmail specifically. So this first one, logging in with Gmail, and these are the conditions to do it. This one specifically has information retrieved from Google Cloud Platform. And these 2 is to check if the user already is in our database or if the user is already logged in on this one. So when there's success in the specific route, the user gets redirected to the dashboard. Still in the login logout part to complete this step, we now need a separate route to take care of the logout part. So it's going to clear out the session, it's going to flash the message saying you have been logged out, and it's going to redirect to the login page again. Now with the registers logins part out of the way, now Gate users are redirected to the dashboard, and this is the route that achieves that. So login is required, this decorator ensures that, modifies the function to accomplish that, and it's going to return the render template index.html. I just changed the name to dashboard as is usually how it's called. Now about the page itself, now we're going to have another route here. The point to this is, if the user is logged in, it's going to retrieve the client's employees from the database. Remember that you as a Gate user, you can add a bunch of employees. And it's cool when you are on your dashboard, you can see like all the employees that you've added. So we need to have a way of displaying that specifically for that user. But I also had to do some changes here so that I wouldn't have users from all the database, but only specifically to that GATE client ID. This is where it's coming from. So from the employees, we are filtering specifically for that GATE client ID user. And we're going to show all his employees in his dashboard. This GATE client that we are seeing here is saying that the GATE client is not defined. And this is because I left this commented down initially. So I need to uncomment this so this error moves. There you go. So now we're in the clear. And now we need to take care of the most important part from the GATE user for his ability to add clients to the database. And to do that, this is the code that accomplishes that. So here this is get and post. As I explained, get is to see all the information that it added to the database. So let's say you as a GATE user, you enter your dashboard and you see all the employees that you added. This is where you get the get from, specifically to the employees data. So it's name, age, job, and income. And you're going to commit that to the database. And then we're going to save it. And this next part is about the second table, so the employee photos. So we're taking a bunch of pictures from the employee when we are creating his record. You're going to save those photos. You're going to commit those to the database. And when we are finished, we're going to flash a message saying added to the database. Same as before, to explain, this route renders add employee HTML. And now this is the render specifically that takes care of the pictures, and I'll explain to you how this works. So it's a post method, so we're going to add information to the database. Locally, we're going to construct a folder path for that specific employee. So we will be seeing, let's say, employee, the ID is number 1. So 1, then his name. So let's say 1 John. We're going to replace empty spaces with an underscore. And using the base directory, we're going to add information to it. So what I mean is, let's say you have like 1 John. So inside that folder, you're going to have photo 1, photo 2, photo 3, photo 4, and so on. And the name itself of the file comes from here. So again, employee ID. So it's 1 photo and then 1, 2, 3, 4, and so on. This is why we're using enumerate, because we need the index as well. As I explained before, so we're going to save the information to the database, but we're going to write the photos to the disk. Same as before, as I explained in my methodology, we're going to save all the useful information to the database, but in regards to training the model and making inferences to a new instance when you have a person that you want to recognize, you're going to use the information directly stored on the disk. And this is why I have this path specifically here. So we are storing the photos from the employees specifically in the disk. Note here specifically, whenever we are returning JSONified responses, we also display the HTML status code. So 200 for successes and the 400 series and 500 series for errors. Now still within the employee theme, now we have another route to finish the session. So getting the existing employee ID and finishing the session. So what is ResNet 50? If you go online, it's pretty much gibberish. People keep regurgitating the same thing over and over, which suggests, beside the authors and very few exceptions, they don't really understand how this works.
You don't find that suspicious?
And since you are not most people, because while you're watching this, I'm going to explain to you exactly how this works.
You have my undivided attention.
Let's get started. Key concepts to understand first. What is a neural network? Say you want the computer to classify, based on certain external things you watch, if the car is a Lambo or a truck. The output is Lambo or truck. So when you provide a picture of either, you want it to figure it out by the things it watches. So what are the things it watches? Well, it can be width, length, color, design aspects, tire size, and so on. These are the features. But you don't tell it these. These are derived from the raw data. The computer does this by itself. Neural networks classify data based on features derived from the input data, rather than predefined characteristics. And since the computer doesn't know which one is which, it starts off with randomly assigned weights for each feature. So say something like this. It will train on this information, but it needs to know the correct answers as it is training. So say we start with a Lambo picture. The computer doesn't know which one is which. So when it goes through it in its first forward pass, it will calculate some weights and biases in the end. And then it sees the correct picture. And my dude is like, Okay, so we are off by this much, the error or bias, same thing. So it does a backward pass and makes the weight corrections for that output, with the whole purpose of minimizing the error.
USA! USA!
As you keep feeding it more pictures with the correct assigned labels, at one point it will get the weights for each feature that are close to the correct ones, as it keeps reducing the error. So whenever you feed it a picture, given the weights and biases it has assigned to each layer and its error, it will be more on point. So it uses the pictures you have in the training set, typically 80% of it, and has the remaining 20% part of the pictures reserved as a test set. We can also have, like we did in the banknote authentication video, a validation set where these are completely unseen pictures, so we can remove any biases from the training test processes of that initial data set. Backpropagation and backward pass. Backpropagation is the calculation of the loss function derivatives in that layer. Backward pass is all the backpropagation calculations from the end to the beginning of that epoch. It's specifically about adjusting weights based on the loss calculated after the fourth pass.
How'd you guys get in here? Visiting hours are over.
Special treatment.
Epochs and batches. One go through the whole network, forward and backwards, it's called an epoch. But instead of going through the whole thing at once, it goes in smaller chunks, called batches. Batches are the sample size you take from your training set. Say you have 100 pictures of the Lambo and define a batch of 10. It will take 10 random pictures from your training set for one epoch.
Look, Fuzz, I got the buzz. This meeting is adjourned.
So one epoch is one forward and backwards pass through all the 100 batches, although it does a forward and backwards pass through randomly selected chunks of 10. Activation function. The activated function transforms the weighted sum of inputs into a non-linear output value. One of the most used ones is ReLU. It deliberately introduces non-linearity to allow the function to be more generalized. The key here is to be able to grab other values that wouldn't be caught if it was always a linear relationship. This is used in the hidden layers. Softmax. It is used in the output layers. It converts the output in probabilities between 0 and 1. Math behind neural networks. As for math, one neuron, we have this expression, note the bias or error term, and we have the activation function. But since we have multiple inputs, it's the same idea but with many of them. Instead of layers, think vectors. Neural networks, one input, one hidden layer, one output layer. Deep neural networks, one input layer, multiple hidden layers, one output layer. Hidden layers. This refers to the layers between the input and output layers. Whenever you see or hear layers, think vectors and an engine. 1. You have the input vectors. 2. Hidden vectors inside the engine. 3. Output vectors outside the engine. For the most part, the more hidden layers, the better, as you will be able to do, in theory, capture more patterns. Cross entropy. Entropy is a measure of randomness. From information theory, which is math theory applied to computers, here specifically we are referring to a measure of how two different probability distributions are. We want to quantify the difference between the predicted probability distribution and the true distribution. Lower is better. So cross entropy is used to define the loss function. This is sometimes referred to as log loss as well. Vanishing exploding gradient problem. How can you calculate a solution unless you understand that first you have to deal with a problem? Anyways, let's continue. If you want to provide as many features as possible so that the neural network can do its thing, you would think that by having a bunch of layers would be a good thing. It turns out that yes, but with caution. Here's why. In the beginning, we do the first forward pass. The model weights, or parameters, are initialized randomly. After passing through all the layers, the network outputs a prediction. After the first forward pass, a loss, or error, is computing, comparing the true label to the predicted one. We do our first backward pass, computing the loss with respect to the model weights. by calculating the gradient. The gradient is a vector that contains all the partial derivatives of the loss function with respect to each parameter. So here, to be clear, we are doing the partial derivatives of the loss function. Why derivatives? Because we are looking to minimize the loss function. Then the model weights are updated. New weight equals old weight minus learning rate times the gradient. Learning rate is a hyperparameter. It can be adjusted to improve the model. There are a couple of methods like grid search, random search or Bayesian optimization where you specify a bunch of learning rates and it tests those out. One used here is ADAM, from Adaptive Moment Estimation. It is an optimization method in machine learning. It adapts the learning rate for each parameter to improve convergence. So here in the vanishing exploding gradient problem is where normalization techniques such as batch normalization and architecture choices to introduce nonlinearity like ReLU come into play. What is a CNN? Instead of fully connecting all the neurons like traditional neural networks, CNNs use filters, also called kernels, to scan the input. These filters are smaller matrices that slide over the image and create feature maps. In this manner, they detect local patterns in the data, like shapes, objects, and so on. Each time you shift the window is called a stride. CNNs often downsample the spatial dimensions of the input using what's called pooling layers. With these concepts out of the way, let's get to the ResNet 50.
That's great.
What does it do? ResNet 50 classifies images, one object at a time. It can do multiple classification in one image, but single classification is its core strength. This is John, this is Robert. So we use ResNet 50 for image classification, like we are about to do in this video. What is it? ResNet 50 means residual network with 50 layers. One input vector, 48 hidden ones, one output vector. It's called ResNet because it's part of their residual network family of neural networks, using the concept of residual blocks. It is a deep convolution neural network, CNN, so deep because we have more than one given layer, convolutional because it uses a kernel that passes through the image to find patterns, to extract features. ResNet 50 is pre-trained on the ImageNet dataset, which contains 1,000 diverse object categories. This brings us to the concept of transfer learning. Pre-training on ImageNet allows ResNet 50 to learn general features that are useful for many image classification tasks. It brings in previous knowledge, meaning pre-trained weights where the model can be fine-tuned for specific tasks with much less data and training time. Think of it like this. It already has an idea of what it's looking for. It just doesn't have specifics yet. About the residual block, why is that? ResNet 50 is designed to address the problem of vanishing gradients. How does it do that? In common CNNs, each layer learns a new transformation from the input and passes it forward. In residual blocks, instead of a full transformation, it learns a small change, residual. It introduces the concept of skip connection, allowing the input to bypass one or more layers when these are not relevant to the current weights it already has in the model. It uses the concept of direct path for gradient flow. In a standard deep network, gradients must flow through every layer during backpropagation. With residual connections, there's a direct path for gradients to flow backwards through the network. This direct path helps prevent the gradient from becoming too small, vanishing, as it propagates through many layers. About its architecture. Contrary to statistics where we have residual equals observed minus expected value, here residual means the leftover information the network learns. About the model math, instead of output equals fx, here we have output equals fx plus x, where x is the input from a previous layer. Fx is the learned transformation by the residual block, the small change the network is learning. It is also called residual mapping. So fx plus x is the final output. If the layer doesn't learn anything useful, say fx is close to 0, the input is passed. If it learns something, fx modifies the input. This makes it easier for the network to maintain performance, even as depth increases. You good? So, ResNet 50, good for image classification tasks. It uses a bunch of hidden layers and has a method of skipping irrelevant ones to produce a better model than standard CNNs. Now that we have an understanding on how the ResNet 50 model works, let's implement it back in our Python code. I'll explain to you how this works. Again, so this is the app route and it's train the model, and the method is post because we are sending information to the server. Login is required, and now this is a function itself. So here we define the base directories for the model inputs. So the employee photos, so the photos that we're going to take from John, so photo 1, 2, 3, 4, and so on. But we also have an environment photos directory for the environment photos without any employees or objects added to it. That way the model can identify when no objects are present in the environment. So by default, the environment is access denied, and as soon as we have something added to it, meaning a pen or a coffee cup or a book or whatever the case might be, those I named as employee photos. It's just me here in my home and my cats, but you get the picture. I just tested this out with a multiple number of objects, but you get the idea. So environment photos, so place that we are going to make the recognition without any people added in it, and employee photos, the ones that we are going to take from the employee that we are adding to the database. And this will be the base directory for the training classes. So you're going to have a new directory here, so it's app, and inside of it we're going to have a new folder called training classes. So here in our model inputs, so let's create the folder. So we're going to have model inputs. This will be inside of app. Okay, so this goes inside. Yes. And inside here, inside of model inputs, we're going to have environment photos, and the employee photos are going to be created dynamically. So all we have to do now is just copy the environment photos. I have the folder right here. So these are photos for you to see. So this is the empty environment. I just zoomed out the camera so that it can only see the wall. In addition, I also created versions of the environment when it's only black. Let's say someone covers the camera when there's no light, no clear picture for that specific situation. And I also have some white ones here. So now when the model is going to be created, it's going to set up a new folder called training classes, and it's going to copy all the environment photos and all the employee photos taken when we added the employee to the database. So this is the function that is going to copy all the photos to the specific directory that we have defined, and this is the training code. This initializes data augmentation for the training images. This one normalizes pixel values and converts images to the format expected by the model. This one randomly rotates the images by up to 20 degrees. These ones randomly shift images by width and height. Same with these, so this is shearing, this is zooming. This one randomly flips images horizontally. And this last part is the validation set. It's going to reserve 20% split for the validation. The whole point to this is to create variation so that we want to avoid overfitting. It will still overfit if, let's say, you have a person in the picture and you have like a bunch of pictures from that person. So it's not necessarily a problem. So let's say it's 2 plus 2, you know it's 4. So you have enough training data for you to understand that 2 plus 2 is 4. As long as you keep seeing the same pattern, it's going to obviously overfit. It doesn't have any doubts whatsoever that whenever you see 2 plus 2 is 4. So whenever it sees you in the picture and you have enough information to train the model as such, it's going to always identify you and not anything else. But still, this is a way to avoid overfitting in more complicated models, with the whole point of creating variation in the data set to increase variety. For the next one, for the training generator, so this is the image size, this is a batch size, so this is a categorical classification, and the subset is training. And for the validation, the same thing. So we have 80% allocated to this part, and we have 20% allocated to this part. So these are the diversification parameters, and this is for the training part, and this is for the validation part. These are just some prints that I added to understand what was going on during the training part and the validation part. This will load the pre-trained ResNet 50 model without top layers. This is why we have the include top false. We're going to add a global average pooling layer to reduce spatial dimensions, and a dense layer with 1024 neurons and the ReLU activation. The whole point of this is to avoid the vanishing exploding gradient issue. And finally, we add a final dense layer with a softmax activation for classification. This next part freezes the pre-trained model, so it's transfer learning, and we're going to configure the model. So we're going to use Adam Optimizer with 1.001 learning rate and using categorical cross-entropy loss for multi-class classification, tracking accuracy as a metric. Here I tested this for a while and found that after 4 epochs, the model was not improving. And since I kept getting this out-of-bounds memory error, I set it to the max, which is 4 epochs. After training the model, we finally save it to the database, both the model and the label dictionary. Now we can start working on the recognized employee endpoint. So to do that, we're going to do this part. So recognizing the employee, again, login is required. So this is the function. Current gate user ID, and we are using all his employees that he assigned to his own database. And obviously he needs to be logged in. To start recognizing the employee, we need to load the model that was trained, so we do that here. And now we need a function to make a prediction using the given model and the image. So we accomplish that by doing this. Saying false here, what we are saying is that we are indicating that the model should be in inference mode rather than in training mode. And now we need an endpoint that takes an image as an input. It's going to process it using the machine learning model that we created, our ResNet 50, and recognizing the employee, with the whole point to returning a JSON response with a recognition result. And we do that by this. So here we are using our logger information, so we're requesting the files that we already have because we saved those. This is the logins part. Here this is a fail-safe because obviously you can't recognize anything unless you have a model trained. So we will see in the page saying that the model is trained or the model is not trained. So if it is trained, you can recognize the employees and it's going to make an inference on that image. The images must be sent via form data, so these are errors that happen if that's not the case. When we do have a red image file, now we are ready to make our inference. So this is the prediction spot. So this initially is going to resize the images as 224 as the model is expecting. And here we're going to pre-process the inputs and make the predictions. And here are the metrics that we are going to see about the confidence and the predicted class. As I explained before, the environment photos are unrecognized by default, which makes sense because you don't have an employee entering, you just have an empty canvas. Else we have something there. And here this is a fail-safe if our image failed to be processed. And now we also need an ability to remove the employee. I didn't add it before, but we will do that now. When we add an employee, we also have the ability to remove it. And it's important because let's say John works at a company, so it's added to the training model. So we have a model trained with John included so that when he gets to the gate, he is recognized and he gets a pass so he can go. But if John doesn't work there anymore, we need to remove John from the database so that the model is retrained again, it's fine-tuned again. And then when, let's say, John that doesn't work in the company anymore and he actually goes to the gate, now he is not recognized, so access denied. These are fail-safes because obviously we can't remove an employee that is not there. But if he is in the database, we're going to remove all his information and the information from the training classes. So all the name, age, income, and all that stuff, and his employees as well. And when we do that successfully, we're going to display a flash message saying employee and photos removed successfully. Or in the other situation when we had an error removing that specific employee. And finally, we need a route to clear the model. So when John gate user creates a model and then he logs off in our specific web app and then we have Stuart logging in, we need to clear the cache from John's model so that when Stuart kicks in, his model kicks in and not John's. And finally, we're going to call the function. The only new addition here from what we have seen before is this db create all. What this does is If the tables were already created, meaning let's say you created all the table headers and have information there, it's not going to create the database tables. But if you didn't create those yet, it's going to create those in accordance to the classes that we defined before, the gate client, the employees, and the employee photos. App run with the host all zeros means that it can run in any IP on port 5000 and not in debug. Inside this file, we're going to have a Gmail client secret. You're going to have Gmail client ID. You're going to have our best directories and model path and label directories. We already have model inputs, and now we're going to create a different folder called model outputs. So model outputs, and get this folder inside app as well. Yes. So the model is going to go inside model outputs and the label dictionary. As for the database, you're going to define the database specifically. In my case, is DB3, and you're also going to define the user and password. So you're going to say Postgre user here. You're going to find your user here and your password. Something here. In my specific case, it's admin for both. And here we're going to define the database URL. So it's Postgre admin, and then the database. This is the port, and this is the database name. In addition, for the database, we can also define a secret key. Inside here is gibberish, and define the type of Flask environment. It could be staging, development, and so on. In our specific case, is development. Now you might be wondering, where does this come from? This comes directly from Google Cloud Platform. When you establish an account there, it's going to give you these keys so that you can put these there. When you go to APIs and services, here I created this gate. So you want to manage this account, create gate. And here is the client ID, the creation date, secret, and creation date as well. Here are the authorized origins and redirects. Note here this is localhost, so 5000, same as we defined before. And this is the redirect when the user is authorized. As for this one, you can use Python to create a complicated key, or use some keygens already available online that can generate a key for you. Alright, with the end file out of the way, we also need to take care of the front end of the site. For that, I'm just going to copy a folder that I created here. This folder static contains the CSS parts. It contains the gate PNG that I created, it's just some gate, the Gmail logo that I found one online, the favicon ICO, which is the G as well, and then some JavaScript code, and the templates. Here we have the index, we have the login, we have the recognize employee, and the register. Don't worry too much about this part. Again, our focus here in this series is from the backend side and training the machine learning model. I'm just going to provide these files directly for you so that we don't waste too much time on this part and just focus on what matters, which is the machine learning part of things. Right, we're almost done. Now we need a couple more things. We're going to need a Docker file and a Docker Compose file. What do these do? The whole idea to Docker is to containerize the application so that we don't have one of those, it works on my computer, bro, and it doesn't work on his. So this way we have all the parameters, all the imports, and all that stuff. It's kind of frozen in a specific image. That way it works everywhere. This is the format. So we're going to define the official Python image from the Docker Hub. We're going to install dependencies that are required and the Postgre client. So it's from and then one. We're going to define our working directory in a container. So you just can't copy all this stuff because it will work on yours. We're going to copy the requirements text file to the container. We'll get to the requirements text in a bit. Here it's about the default timeout. So this is a way to increase the time to get the requirements packages inside of the Docker image. Here is how we are going to install the requirement packages. Here, this is a syntax to copy the rest of that application code to the container. So it's going to copy all the stuff that we have here. This is also going to create necessary directories. We're going to need this one specifically. It's going to create that specifically to test. You're going to expose port 5000. and this is the command to run the application. Again, this is in YAML form. Don't worry too much about this. It uses a different syntax. You just pretty much copy what they have here and it will work. Now we're going to use Docker Compose. So you're going to create a new file, Compose in YAML. YAML means yet another markup language, and this has its unique syntax. But what is this Docker Compose, first of all? If a Docker file is a musician in an orchestra and you have like a bunch of people that compose the orchestra, look at Docker Compose as a maestro. So Docker Compose will control and manage all the Docker file images. We're going to have a specific set of commands in order to do that. We have three things here. We have networks, so it is a network between all what we have and Postgre, so all of them are inside a network. You're going to have volumes. This is how this is structured. So it's Postgre data, employee photos, model outputs, and logs. This is a part for the volumes. And we're going to have a couple of services. Inside of services, we're going to have the database, web, and backup. Inside of the database, we have image, so container name, we have the environment, ports, volumes, and networks. All this information is here. Inside of the database, we have image, we have environment, we have ports, volumes, and networks. Note that the network is the same. This is how you define it. And just close the database here. Inside of web, we have build, we have ports, we have dependencies, we have environment, volumes, and again, network. I'm going to show you this again. So the ports are 5000, depends on the database. We have the environment set up with the Flask environment database URL, all the keys that we have directly from the .env file, and the model and label paths. We're going to have the volumes that it uses. This refers to the volume. So we have the app, we have employee photos, where we defined here this before. We have model outputs, and we have the part for the training classes. Specifically here, I also defined another one to back up the Docker file. Now about the requirements. Since we are creating an image that has all the stuff and can run anywhere, we need to import to it the requirements to our file. And to do that, we're going to do pip freeze. Then like this, requirements.txt. So now we have a file here with all the requirements to make this work. Now let's create our Docker image. So we're going to do sudo docker compose up build. It's going to take a bit. I'm going to show you how this works so you can do it for yourself as well. While we're at it, note here that I have added some folders, but the structure is exactly the same. These are some test folders that I did before, and I wanted to see some different parameters before doing this video again for you. And we're done. Note here that these warnings, these are for the CUDA part, that I don't have this machine because this is an older computer. It's still a powerful graphics card, but it doesn't have the requirements for TensorFlow and for PyTorch. We are using TensorFlow. It doesn't have requirements for PyTorch as well. But nevertheless, this is why this is showing up. So now when we load up our browser, and now we are back here in our register form. I'm going to use, let's say instead of Google, just use my email. Say it's evomathcat. Cat, this is me. And then evomathcat.yandex.com. Then some random password, it really doesn't mind. I simplified this a bit because I didn't want the burden of like receiving emails to confirm the registration and so on. Because our focus is not much that part or like the front end to have everything pretty. I just want this functional so that we can focus all these series in the machine learning part. Nevertheless, you're still going to get all the code from GitHub. I just wanted to focus specifically here on our part for the data science machine learning part. So we're going to register. It's going to get in. Yes. We don't have any employees yet. And now in our future amazing billion unicorn startup, I'm going to show to you how this works. So add new employee. Let's say it's me. So Diogo, then my age, then job, salesperson, and then my income. Let's make it a cool 160 million. Or I just add another zero to make it 1.6 billion, makes it cooler. I'm gonna start a different camera from the main one so it's more practical for me. Obviously, it's important to take from different angles, but just for the sake of it, we're going to keep this super simple. But you get the idea, because let's say you have a mug has different parts to it, like part that you hold it and all that. So just to get the idea. Right, so we're going to finish the photos. You're going to add the employee. Right, with the employee added, now we're going to train the model, because if we went directly to recognize the employee, it's not there yet. So we need to train the model first. Right, now this has changed. We can see the model trained and saved successfully. So now we can recognize the employee. So we're going to go here. We're going to start the recognition. It's going to start a little bit. I put this animation here in the beginning so that people wouldn't think it wasn't working. It is working, it's just loading the model. So initially it takes a little bit, and then it's faster when it's making the recognitions. Right, so it's recognizing me. When I leave the picture, it's going to say unrecognized. And when I come back, get this again, it's recognizing me again. So this is how this works. So we're going to stop the recognition now and going back to the main page. And now what's interesting about this, let's say someone works at a company, so the model was trained so that that person could enter the company because it's recognized as a person that works in the company. But now this person leaves. So we're going to remove this person from the company. So we're going to remove the employee and update the database. And now we're going to train the model again so that the next time it's not going to recognize me because I'm not in the model anymore. So we're going to train the model again. And now we have the new model trained without me in it. So we're going to recognize again. And now when we start the recognition, now when the model finishes loading, it's not going to recognize me anymore because I've removed myself from the model. I'm going to take a bit. See, I'm not recognizing anymore. Even if I leave the picture, it's not recognizing me anymore. So this is in fact working. So we're going to stop the recognition. I'm going to go back to the main page. All right, now back to our IDE. If we want to terminate the project, we can open a new terminal. And just clear this out for you. You're going to need to enter the folder again. So the cdgate project. Need to activate the virtual environment again. And now we can bring Docker down. And to do that, we're going to do docker compose sudo docker compose down. So now this is going to bring down the image so that it's not online anymore. Right, now that this is down again, I want to show you how this works so you can get your image up or down again. So you do sudo docker compose down when you bring it down, or up if you want to bring it up again, but you haven't made any changes. So this is when you don't have any changes in your code and you just want to bring the image up or down again. So it's up or down again. In addition, still in the down part, if you want to get all the stuff down again, let's say you want to train a new model or you change something in the code, when you have your volumes as they are presently are, you will have persistent memory of stuff that you did before, and that will come as a conflict with, let's say, new information that you have, like, you know, databases or whatever the case might be. So it's a good idea to clear the volumes, and you do that by doing -v. So when you do that, it's going to clear all the information. I'm going to do this for you right now. See the difference now? Now we have the volumes that were brought down. And there you have it. I hope you enjoyed this video. Remember to subscribe and click that notification bell so you'll know when I make more videos like this. Peace.